Hey viewers, today we are taking a look at how refrigerators work. Refrigerators have a coil of hollow tubes running through them, usually made of metal. Through these tubes, a refrigerant flows, which carries the heat from inside of the refrigerator to the outside, usually the back side of the refrigerator. So how does that work then? As we all know, warm things become colder and cold things become warmer. So how can we then transport heat from inside of the refrigerator, where it's cold, to outside of the refrigerator, where it's warm? The answer is simple. We need to make sure that our refrigerant is colder than the inside of the refrigerator and warmer than the outside air. Since it is impossible to do this at the same time, we will need to do something to change the temperature of the refrigerant when it crosses the border between the inside and the outside of the refrigerator. The most common solution to this is changing the pressure. In formula, we look at the refrigerant and see that PV divided by T is constant. In this, P is the pressure, V is volume, and T is temperature. This is called the ideal gas law. Although this is technically only true for ideal gases, it can still be considered true for real gases. If PV divided by T is constant, then it follows that PV divided by T before the pressure change is PV divided by T after the pressure change. Since we are talking about a closed system here. Since V, the volume, is constant, with the tubes on both sides being equal, we get that P divided by T before is P divided by T after. This is called Gay-Lussac's law. This gives us the direct relation between the pressure and the temperature. If P1 is higher than P2, meaning that we are going from high pressure to low pressure, we see that T1 must be higher than T2 for this equation to hold. The same goes for the reverse. If P1 is lower than P2, meaning we're going from low to high pressure, T1 must be lower than T2. Note that a bigger pressure difference between the sides results in a bigger temperature difference between the sides. In addition to the pressure effect, a secondary effect is used to cool the refrigerant. This effect is called auto-refrigeration. By picking the pressures used in the system such that we don't just have gas, but rather a gas-liquid mixture, the rapid decrease in pressure will make some, typically about half, of the available refrigerant to evaporate. The heat required for this is drawn from the surrounding liquid, cooling it down. The evaporated liquid will turn back into fluid when it is compressed again, releasing the energy it absorbed in the evaporation process to the surrounding refrigerant, making it warmer. By using this effect, the refrigeration process becomes more energy efficient. Since we now have a cold and a warm side of our system, all we need to do is stick the cold side inside of the refrigerator and put the warm side on the outside. This way, the heat inside will go from the warmer air to the colder refrigerant, and on the outside, the heat will go from the warmer refrigerant to the colder surroundings. There is a second system that uses the exact same setup. It is called a heat pump. A heat pump is a device that draws heat from the earth, for example from groundwater, to heat up, for example, a building. The principle is the same, only reversed. The cold side goes underground, where the refrigerant will absorb heat from the groundwater, and the warm side goes in the building, where it will give off its heat to the surrounding air. It's a really energy efficient way to utilize earth warmth for heating up a building. I hope you learned something today, and I will see you next time.